We measure distance in space. Light is the fastest thing we know. It's so fast that we measure in moment distance. By how long is 10 for light to travel then? In 1 year, light travels about 6 million miles. At distance we call 1 light year. To give you an idea of check how far this is, the moon visits to the Apollo instrument Friday. Tourist is only 1 light year second from Earth. Is one the nearest star beyond our vision. Our Milky Way is on the order of 100,000 years. The nearest galaxy to our Andromeda is about 2.5 million light years away. Space might very vast, but why how do we know how far away stars and galaxies are?
After all, when we look at the sky, we have a flat, two-dimensional view. If you point your finger to one star, you can tell how far the star is. So how do astrophysicists figure that out? For objects that are really close by, we can use concept called trigonometric correlates. The idea is pretty simple. Let's do an experiment. Stick out your thumb and close your left eye. Now, open your left eye and close your right eye. It will look like your thumb has moved, while more distant background object has remained in place. The same concept applies when we look at the stars, but distant stars are much farther away than the length of your arm, and the Earth isn't very large. So even if you had different telescopes across the equator, you not see much of a shift in position. Instead, she looked at the change in the star apparent location over 6 months. We have 3 points of the Earth's year-long orbit around the Sun.
When we measure the relative positions of the star in summer and then again in winter, it's like looking with your other eyes. Nearby stars seem to have movement against the background of the more distant stars and galaxies, but this metric only works for objects no more than a few thousand light years away beyond our one galaxy. The distance are so great that the parallax is too small to discrete with over more sensitive instruments, so as the points we have to roll it on a different method using equator. We call standard candidates. Standard candidates are objects whose intrinsic brightness or luminosity we know really well. For example, if you know how bright your light bulb is and you ask your friend to hold the light bulb and work from you, you know that the amount of light you receive your friend will decrease by the distance.
So by comparing the amount of light you receive to the intrinsic brightness of the light bulb, you can then tell how far away your friend is. In astronomy, our light bulbs turn out to be a special type of star called a Cepheus variable. These stars are internally unstable, light are constantly inflating and deflating balloons, and because the expansions and contractions causes the brightness to vary, we can calculate the luminosity by measuring the period of this cycle, which more luminous stars sinking more slowly. By comparing the light we observe of these stars to the intrinsic brightness we have calculated this way, we can tell how far away they are. Unfortunately, this is still not the end of the story. We can only observe individual stars up to about 14 million light years away, after which they become too various to success.
But luckily we have another type of standard candidate, the framework type 1A supernova. Supernovae giant time expression are one of ways that stars die. That expression are so bright that they outshine the galaxy where they occur. So even when you can see individual stars in the galaxy, we can still see supernovae when they happen. And the 1A supernovae turn out to be usable as standard candidate because it is crawled by one phase slower than phase 1. Track our understanding of this relationship between brightness and desired rate. We can use this supernovae to plot distances up to several billion of light years away. But why it is important to see such distant objects anyway? We remember how fast light travels. For example, the light emitted by the sun will take 8 minutes to reach the
that the light we see now is a picture of the sun 8 minutes ago. When you look at the big dipper, you are seeing what we look at light 3 years ago. In those smudgy galaxies, they millions of light years away. It has taken millions of years for that light to reach us, so the universe itself is in unseen and in real time machine. The future we can look back. The younger the universe we are probing it. Astrophysics try to read the history of the universe and understand how and where we come from. The universe in constantly sending us information in the form of light or death. Remind it for us to decide it.